Welcome to another session of Ebenezer Key coaching classes. This is a multiple choice question for 2 marks. A unity feedback control system is characterized by the open loop transfer function g of s equal to 10k into s plus 2 by s cube plus 3s squared plus 10 to Nyquist path, and the corresponding Nyquist plot of g of s are shown in the figures below. If k is between 0 and 1, then the number of poles of the closed loop transfer function that lie in the right half of the S-plane is. Now, according to Nyquist criterion, the number of encirclements in the anti-clockwise direction is P minus Z, where P is the number of poles that lie in the right half plane and of poles of open loop transfer function. And Z is the number of poles of closed loop transformation. This is what we are interested. The number of poles of the closed loop transformation is what we are interested, that lie in the right half, which there should be no pole in the right half of the S, lie in the right half of the S plane. Okay, now, so we should know what is the number of poles of the open loop transfer function in order to find out what is the number of poles of the closed loop transfer function. Now, we are shown in this diagram that the Nyquist plot of g of s, is encircling the origin in the anti-clockwise direction 2 times. So number of encirclement of the origin, n of origin, is 2. N of origin is 2. Here, this n is encirclement of -1 plus j0. But now I am just telling you, I am finding out the encirclement of origin. This encirclement of origin, let me say NO should be P minus Z, but in this case, P is the number of poles on the right of plane in RHP, and Z is not poles, number of zeros in RHP. In this case, both are for the open loop transfer function. So this is to find out the number of poles of the open loop transfer function which are in the right half of the S-plane. Now here, if you take g of s, here it is very clear there is 1 0, s is equal to -2. So there is no 0 in the right half of the S-plane. So in this case, z is 0. So number of encirclements of the origin is equal to the number of poles in the right half of the S-plane. So for an open loop transfer function, if you want to find the number of poles of the open loop transfer function which is in the right half of the S-plane, then the Nyquist plot which encircles the origin in the anti-clockwise direction is N0, is given by P minus Z. Here Z is very simple because S is equal to the denominator is a cubic equation. So to find out the number of poles in the right half of this plane, we'll have to use Rauther criteria. But here it is very simple. If you have an Nyquist plot of G of S, the number of encirclements of the origin in the anticlockwise direction n0 is equal to number of poles minus number of zeros. Number of poles, 0 is very simple, s equal to minus 2. There is no pole, no 0 in the right half of this plane. So z is equal to 0. Z is equal to 0. N0 is equal to p. So here number of encirclements of the origin in the anticlockwise direction is 2. So 2 equal to p minus 0 or p is equal to 2. That means 2 poles are there in the right half of the S plane for the open loop transfer function. Now I go to the closed loop transfer function. To analyze the closed loop transfer function, again n for the closed loop transfer function is p minus z, where p is what we have already found out, that is for the open loop transfer function, the number of poles in the right half of this plane, that is 2, minus z is not known, we have to find out, and number of encirclements of the closed loop transfer function, let me call it NC, is how much, let us see. Here we are told k is between 0 and 1. So if k is less than 1, then minus k will be greater than minus 1. So minus 1 is somewhere here, and there is no encirclement of minus 1 plus j0. For a closed loop transfer function, we'll have to find out the encirclement of minus 1 plus j0. So the encirclement of minus 1 plus j0 is not happening. So it is 0. So NC is 0. NC is 0 is equal to 2 minus Z. That means Z equal to 2. That means there are 2 poles of closed loop transfer function which are in the right half plane. So the answer is 2. So the number of poles of the closed loop transfer function that lie in the right half plane is 2. Once again, n is the number of encirclements. Since k is less than 1, there is no encirclement. So n is 0 and 0 equal to p minus z. P we have already found out is 2 poles are there in the right half of this plane of the open loop transfer function. 2 minus z is equal to 0 or z equal to 2. Z is the number of poles of the closed loop transfer function, which is 2. Thank you. God bless you.